Hi guys, this is part 2 on the tree milling machine video. I've got this rolling platform for the machine pretty much ready. These two parts will sort of assemble around the front and back of the machine. There's those bars will go between them. It's got some really heavy-duty cast iron casters and these jacking studs so you can level the thing and take the load off the casters. This will assemble under the machine here. First thing we've got to do is get that transformer removed from there because it gets in the way. And we also have to figure out how to get this off the pallet. The front's pretty easy. The back I'm still trying to figure out. Okay, we've got this up on blocks now. The front end is up on blocks here. We just sort of levered it up. The back end is still supported by, or was still supported by the pallet. We've now got that sort of levered up onto the wheels. So the pallet is now completely loose, so we should be able to just pull the pallet out from under it. Probably just going to push in blocks as the pallet goes out just so that it can't fall very far. Finally, that's out. Got this on the ground now and turned around a bit, sort of near the final position. I've removed the shelves that were over here, and also started working on fixing some of the problems with this thing. I've removed this transformer. It used to be right in the middle there, right where the wheel is. I just temporarily wired it in. I'm not sure if I'm going to keep this or switch it for a switching power supply yet. On the inside, there's a couple of problems I've noticed. Simple thing, this fan is not rotating properly. I think it's just because they put this guard on backwards. You can see this one has this mounted with the guard far from the fan. This one they put it on upside down, and it may be a bit difficult to see this. Let me get a light. I noticed that this fan, the blade has actually fallen off, and it's you'll see the blade is actually down there inside. So I've got to take the cover off the controller so we can put the blade back on this fan. It's somewhat difficult, but we can just get these fans out without having to take the whole controller apart. Yeah, it looks like it's just a case of the rotor having fallen off because the snap ring came off. That should be a simple fix, as long as the motor hasn't burnt up for not having an armature or not having a rotor in it. Everything still seems to be here. It just seems to be a case of putting some new oil in this. Turns rather freely now. Let's just see if we can get the snap ring back in. It looks like it's sort of worn out. It's sort of shiny. I wonder if it's going to fit. It's all back in there now. It doesn't look the nicest. The snap ring seems to have been thinned out significantly from friction, but it seems to work. Shouldn't be too hard to get this back in with the rear nuts pre-attached like this. Okay, lesson learned. Always label connectors when you're taking them off, even if they seem to be labeled, because not all of them are actually labeled. I had to go back in the video and check to make sure these ones are put on right. Got curious and decided to pull out the switching power supply on this, and that's a really old classic power supply design there. Classic 80s stuff. Looks like one of the wires, ground wires here, has been hitting the fan. It's been abraded here and back there. This was right up near the fan, so I'm going to keep that out of the way. Other than that, it seems good, other than one bent heatsink. And there's the, you can see down there, the backup battery for the battery-backed settings in RAM. That's all back in. I'll do a teardown of this later. I want to figure out which boards have the battery-backed memory on them, because I don't want to end up pulling those out and losing all the settings. Okay, let's give this a try now. It's not right, it should be coming on already. Does he forget to turn something on? Yes, that would help. Let's try that again. Okay, that seems better. Let me just get this out of the way. Seems to be working properly. Looks like everything still works properly. It's been about a week since I was last working on this. A bunch of parts came in from various retailers online. I got some rubber for new way protectors. Still need to hold this up properly. It's got a couple of magnets holding it. I took the aluminum bed off of this, and it seems the table is in pretty good condition actually. A few minor dings on it. The worst is a bit more on the edges where people have been putting tools down, and the only real big one is this, where someone's drilled into it, but it's not really a huge problem. I've also installed central compressed air lines in here for this stuff. There's one up there as well, and a few various other places. The original air filter and oiler was all leaky, so I just replaced it with this one. Seems to work pretty well. Yeah, the old one was one of these, just one of these things in here, and this was all of the seals where this screws in here were all leaky. The next thing to do is going to be adjusting the spindle drive a little bit, because right now when 0 speed is commanded it goes about 200 RPM or so, and I finally found the manual for this VFD, or at least one that's close enough to have all of the pot descriptions and setting procedures. Yeah, I found this, I had to call up Fanuc with the part number of this drive, and they gave me the part number for this manual, and they wouldn't actually give me any quote or anything without me setting up an account, but with the part number I was able to find someone who had it online. Yes, part number B-53425E. Okay, starting off with the first adjustment. It says to adjust RV2 while measuring test point 13, so that when you apply forward and reverse commands with 0 speed, you get the same voltage for forward and reverse. So if it's off, when you apply forward you might get 8 millivolts, when you apply reverse you might get 2, and you have to adjust the pot so that when you change between forward and reverse you get, say, 5. So in this case, we're going to have to turn the spindle on first. Okay, to turn the spindle on we have to go M03, spindle S0, and then cycle start. Or perhaps we have to apply some speed first. Try S100. There we go. And now if we go S0 again, cycle start. Now you can see the spindle spinning when it shouldn't be. And over here we have 18.5, 18.6 millivolts. And to reverse the spindle we go M04. And that should we have to go speed again. S00. We have to actually put a speed in. M04. S500. Okay, now it's going in reverse. And I had some problem when you turn the spindle override down. That's not doing it right now, but when you turn that down it would make a horrible screeching noise. Let's go S0. Okay. Yeah, now it's going forwards very, very slowly. So now we have 19.0 or so. That's actually very close. They're talking about here as an example of 1 millivolt offset, so I don't think this adjustment has really any problem. I'll probably skip that one for now. What does it say next? Next do level. Give the rated command of 10 volts and adjust RV1 until the terminal is 10 volts. Plus or minus 0.05. Now I had a problem with this where when I applied 3500 RPM, which is the specified max speed, the spindle drive errored out due to overspeed. So I'm thinking the gain of the gain may be set wrong, and maybe overdriving the spindle. So let's hook this up to the measure the command voltage and put it up at high speed and see what it's doing. So the analog command should be channel 1. It should be this one. And we're getting about minus 25 millivolts. Let's try commanding a speed now. Okay, we got minus 1.44 volts with commanded 500 RPM reverse. Let's try 500 RPM forward. And plus 1.403 in forward. All of the other adjustments for this seem to be just for the top spindle speed. I'm thinking the problem is this velocity offset. This is just RV13, so the spindle doesn't turn when command of 0 is applied. So let's give that a try. So RV13 is, where is it? RV13 is right here. So let's twiddle that while looking at the spindle. No, it doesn't seem to be doing anything. Yeah, we're changing RV13. It's not doing anything. I'll just put it back where it was initially. Okay, since none of those adjustment pots seem to do anything, I'm thinking the problem may not be in the command voltage. The offset error might be somewhere in the feedback path from the velocity detection circuit back to the subtractor. So let's see if you're looking at channel 20, going over here. Channel 20 is the velocity feedback signal. And I believe that should be 0 when the spindle is stopped. So let's check that. Let's find channel 20. 20 is right there. Right now the spindle is running, so let's just stop the spindle and set it to speed of 0. Yeah, that's very close to 0 now, but the spindle is not stopped. Let's try reversing, putting the spindle in reverse now. Actually, let's just turn the spindle off entirely. I'm not sure if that'll disable the drive though. M05 stops it. That's off. It's still pretty close to 0. Let's try actually driving in reverse now. Okay, I think I narrowed the problem down to the velocity loop offset, because this measuring the velocity loop offset, or the velocity reading, if I set it forwards at a given speed, or when I set it 500 RPM, it reads 1.4 volts. When I set it to reverse at 820 RPM, it sounds like it's going the same speed, but it's reading minus 2.3 volts. So that seems to be where the offset is. So I think we have to change other way. We need to change what is it? Speed detection offset, RV10. Yeah, for the speed detection offset, it says to look at channel 17. Channel 17 is the velocity feedback frequency to voltage output. So that seems to make sense. Okay, now we'll try again adjusting RV10. Let's just record where RV10 is right now. Now we can go and turn that. Looking at the spindle. Ah, yes, there we go. That's better. On focus. Nice. Yes, there we go. She now seems to have gotten sort of stuck. Maybe we should check that test point. Test point, what was it, 17? Yeah, I think it was 17. There it is. 17. I said to adjust that for 0. RV10, is it? Yes. Okay, that RV10 does seem to be the one we need to adjust, but when I set the spindle to 0 volts, when the speed to 0, setting to 0 volts, when the spindle gets close to 0, it just completely shuts down. And I remember the specs for this saying a minimum speed is 50 RPM. So what I've done now is set it to 60 RPM forward, and I'll adjust the pot till we count 1 rotation per second approximately. There's RV10. Okay, the offset is now very, very low. This is the spindle with a command of 0. Hopefully the normal method of adjusting the offset will now work. I'm thinking that because this loop was so far off that the normal control didn't have enough range, the normal offset control. So let's give that another try. Actually, looking at this manual again, it says RV10 that we've been adjusting should be set so that channel 17 is at less than 2 volts when the spindle stops. We're seeing voltages around in the millivolt range. I'm thinking this actually might be plus or minus 2 millivolts. So let's give that, let's adjust the pot for that. So it's more close to following the procedure. So 10, yeah, so that's still available. So there's within 2 millivolts. Now we can try that offset, the other one. Offset again, the one specified. Actually, I suppose Yeah, we can try this one again, RV13. And now when we adjust RV13, okay, it's still outside of the adjustment range. That's about middle right there. That's all the way one way. That's all the way the other way. So it's still, something's still not set. Or maybe I should set that back to mid-range first and then try again. Okay, at this point the spindle drive seems to be adjusted just about as well as I can get it. If you look at the command voltage from the CNC controller, we're getting about minus 25 millivolts when speed command is 0, and that corresponds to a speed of about 8.5 RPM, or 1 revolution every 7 seconds. And I measured 1 revolution every 6.5 seconds, so that matches. That seems to be where the error is coming from. We can correct most of it with that offset pot, but there's probably another offset pot somewhere in the CNC controller. So once I can get the manuals for that, hopefully we can adjust it. For now, we'll just turn this pot as far as we can get it to get this the speed as close as possible to 0. Let's see if now we can run to full 3500 RPM without it erroring out. So let's go S3500. Yeah, that's better. Now let's try that in reverse too. Yeah, still got that very slight rotation speed, but I don't think it'll be much of a problem. Okay, I think it's time to start machining something a bit more complex than the first test part. This is just a simple sort of box shape that's going to be made out of a 2x4. This uses about 3 or 4 different tools, so let's give this a try. Okay, now we'll set up the tool zeros. I've got a bunch of tools set up here. This one here is just a probe. It's 0.2 inches diameter. Up here we have center drill, 3-inch face mill, drill chuck, haven't put the drill bit in yet, a 3/8 inch chamfering end mill, 1/2 inch end mill, 6mm end mill, and a 2mm end mill. So focus on that. Yeah, it's a really small one. And what we have to do now is set all the tool zeros. So we'll set this, I'm not sure if this is the right way to do it, but it seems reasonable. I'm going to set the probe tool to be 0, and then set all of the relative heights, the tool heights relative to that. So I've just put this in here. I've just got this at just so this is just about touching it. If we go 0.001 down, it's now sort of tight and locked in there, so we'll just set that to 0. So now we can just set the put each tool in, adjust the height so it's just touching, and then set all the tool zeros. Now with the center drill in, we just have to move the axis into position. We'll move this down. That's just about there. Now we'll go into stepping mode in 1,000 steps, and we'll just step down until we, now that's right about there. That locks it, so right there. Then we go to tool tables, tool length offsets. This is tool number 1, so we just have to push tool cal, and that sets the offset right there. And this, I'd set the diameter for something else, so we'll just say, I don't think this doesn't really have a diameter, so we'll just go, where is it, D0. And now we just repeat this for all the other tools. For this last one, the drill, it's much longer than the other, so we're going to have to lower the table. Let's just lower it more than we need, then we can put it in. we zero it as normal. Right there. Okay, here we go. I think we have the position wrong. Yeah, I think I referenced it off of this corner. It should have been that corner. Okay, to do this, we'll just move this over here, take it down, slow it down, just approximately touch the edge here. Slow it down again. Doesn't really matter because we're going to be machining around off a bunch of material around the edge, so that's just about touching. Machine it up. Now we'll move it over exactly 0.1, and now it will be right in the center. So now we can zero Y, and then we can restart. I think we had a problem with the servo drive there. Yeah, probably overspeed. I had this problem before. Let's just see if we can press the reset button on the drive. We should be able to reset that now. Yeah, I think we have to restart from the beginning. Okay, we'll just run through the first operation with no tool just to get through that. Okay, another tool change. This time we need the chamfering mill. This will just take a light chamfer around the edge. Okay, this side of the part's done. Now what we have to do now is turn it over, clamp it back, turn it over, re-reference the machine 0 to basically the corner of the vise, and then clamp it back in upside down to machine the other side. So we'll do Z first. To zero that to this to this down. Now we can go in very slowly. Now we'll go in thousandths of an inch down till we hit. That's locked, so that's Z0 right there. Then for Y, we'll just do a little bit of paper. Put it between here and the edge of the vise. Again, now we'll go into thousandths. Okay, so that's about one paper thickness. And if we measure the paper, is about 4 thousandths, so we can go 4 more thousandths in. And that is our, let's go up. Now we can go the amount in. So that is our Y0. Now that the machine's zeroed, we can just put the workpiece into position. Doesn't have to be too precise just for this quick test part, but this will be good enough. Seems solid. I'll just feed it more slowly this time, and hopefully we'll get a better finish. Actually, these are top passes are rough, so we can go faster. The finished passes on there is only the last one. the half-inch end mill again, we'll be cutting out the inside pockets. Actually, no, this is going to do the outside edge. Probably isn't really needed. Let's speed that up now. Now we can probably dial the speed up a little bit. Slow down when it gets near the edge walls of the part because it's going to be very thin around there. Part has about 6mm wall thickness, so because I knew it was made out of wood, so I hope that's enough. This is real-time speed right now. Okay, tool change to the small 6mm end mill to finish up the corners. Dust on all these so to keep it clean. Now there's some stuff about this, the way the solid cam generated this code that I don't like, and I think you'll see why soon. Basically pulls back back out to a safe height position before doing the rapid move back to the starting position, and that wastes a lot of time. Take quite a while. It's one of the longest operations in this program. I'll get this up without jumping down. Okay, now we're going to center drill the holes. Kind of ridiculous for wood, but maybe we'll just get used to doing the operations. And the drill. Now I've done a bit of a cheat here with the drill. I've adjusted the tool offset by 2 inches because there's not enough Z travel in the spindle, so we have to lower the table by 2 inches now. We'll lower it. That's 1 turn. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and coming up to 20. That looks pretty reasonable. Yep, good. It's not doing anything stupid. Probably should have had more of a heck drilling operation though for this depth. There we have it. That came out pretty well. The stringy nature of wood seems to be causing some problems with all these little strings here, and we did get a bit of breakage here, but that's kind of expected with something like this. But that was a pretty good practice run for making these parts in the CNC. Actually, after sanding, this actually doesn't come out too badly. Stay tuned for next time where we'll get this machine backed up against the wall properly and leveled. We'll need to make some sort of a pad to compensate for the non-level floor. Anyway, hope you enjoyed this video. Thanks for watching.